Okay, Advent of Code Day 7. Here we go. Luggage processing. Okay. Required contents. Shiny gold. Okay, let's look at our input. Oh, wow. Okay. So first thing we're going to have to do is some string parsing to get all the information out of each of these. It looks like it's going to be dividing based on comma space. And dividing on the word contain. Okay. Okay. How many bag colors can eventually contain at least one shiny gold bag? Okay. If I... Got you. Okay, so this is tracking how many things can lead to shiny gold bag. So let's think about the best way to do this. It's going to be iteration, and we don't care how many, although I'm willing to bet that's going to be part 2. It's going to have something to do with how many bags of each of the things. So let's let's get those kept track of as well. So we want let's just map them. So we're going to say for line in L, and we're going to want to divide based on bags contain space. Oh, and no other bags. Okay. Tokes is equal to line dot split bags contain, and then we're gonna have this stuff, and it ends in a period. Okay, lots of... Okay, so now we got color is equal to tokes of 0. Let's get rid of this, and we're just gonna print all the colors. Hey, I like that. That's exactly what we're looking for. So the next thing we need to do is figure out all of the bags that are inside of them. So we need to make a set to go along with those. So we're going to say, I'm just going to call it other. And we're going to say, so if we split based on space, that won't quite work. If we split based on bags, comma, then we almost got what we want. So one thing we have to worry about is the contain no other bags. So let's say if tokes of 1, oops, equals no other bags. We just want to get rid of the period. So I'm going to do that in a step. Then we want we're going to want to have this be a list of pairings. So we're going to say let's just do L2 equal to bloop, and then we want L2.append a little tuple, and the tuple is going to be color, comma, other. We're going to say else. Well, actually, we could just say not equal, because that's the case that we want. L2.append, why doesn't it like this? Expected indented block. Oh, because we haven't finished that yet. Okay. Print other. And each of the other ones is going to have... So this set is going to be a set of pairs, but we're going to want to... Let's just say other with num, or other num is also a set, because we're going to want both. Probably the other one's going to be for part 2. So other and an other num. And then we want So if it's not equal to other bags, so we want tokes, and then we want, so let's do tokes2 is equal to tokes1, and we want to get rid of the last character, so 0 through, I think it's -1, or we could just to be safe, we could just say a length of tokes1 -1, and then, so this is it without the period, dot split, and oh, it's gonna be bag or bags. That's so frustrating. Well, if we just split on a comma space, then we'll at least get most of what we want. Split on comma space, and then, so tokes2 is gonna contain, so 5 faded blue bags, or 6 dotted black bags. And that's what we want. So let's just print tokes2. And I want to see how we're doing with that. Untoward operand for minus. Length of tokes1 minus 1. Hey, okay, 2 meters. Clear all of set. Great. That's what we want. Okay, so now we've got to iterate through for t in tokes2, and we're going to get the well, first we want the first, well, we're just going to split on spaces. Tokes3 is equal to t dot split, and we don't need any argument because it's splitting on spaces. And now what we know is the first argument is the num. So num is equal to tokes, or int of tokes3 of 0. So that gets us the number of bags. And then we're also going to have the color of the bag. Let's just say color2 is equal to tokes3 of 1 to, let's just do this again because I don't remember if -1 works exactly the way we want it. Let's just do -1 here and see if it works. 1 to -1. And we're going to say, so now we're ready to add to these sets. So other.add, and we're going to add color2, and then other num.add, we're going to add the tuple color2, and then or actually, other num should be a map. Should be a map for, and then we just don't need other. So let's just say other is equal to a map, and then we can just iterate through the keys, and then we can just say other of color2 is equal to num. So let's take a look at what we've got now. So now let's look at that. Unhashable type list. Excellent. Other of color2 is equal to num. Oh, we forgot to join this. What? That's odd. I could have sworn you could just join strings. Python join list of strings. Let's just Google it. And we've got, it is join. String.join. Ah. Oh, and it's this with this, yeah, that's it. There we go. I remember this. I swear I know how to code sometimes. Okay. Okay, so we've got, let's just look at the very last one just to see if we're doing this correctly. So we've got clear all the bags, and we've got 2 muted gray, 2 dark red, 5 clear brown, 5 bright silver. We're doing excellently. and Posh Plum contain no other bags. Hey, this is exactly what we want. Cool. Okay, I think we've successfully parsed our input in the however long this has taken, 9 minutes. Okay, so we have our input parsed. So now what we want to do is see how many bag colors can eventually contain at least one shiny gold bag. So let's say a list of solution sols, or sols is just like all the things that can contain a shiny gold bag. And I'm going to say while true. So this is a little bit of a hack. I'm just going to print it out, and then when it stops getting bigger, then I'll know that. Well, actually, no. I'm trying to think. Yeah, as long as there's no like weird recursive something, then we should be okay. So we're just going to say while L2.length, or no, we want length of L2 is greater than 0. Okay. For bag in L2. So each of these, it has a color, and it has an other. So so the things we need to check are if there's anything in the key set. So if the key set's empty, then we just remove it from the list. Okay, let's just call, I know we get concurrent modification exceptions when we try to remove things from a list that we're iterating over. So we're going to say rem is equal to list, and then for bag in rem, this doesn't need to be a list, this should be a set. Add. There we go. So for bag in L2, L2 dot remove bag. Excellent. So that removes all of those ones. Okay, so let's first check to see if it has nothing in its key set. If bag dot, well, we want of 0, or sorry, bag of 1. Bag of 1 is other, and other is the map. Dot keys. So otherwise, so we know we have something in our keys. So the next thing we need to do is iterate over the keys and see if any of the keys are in the solution. For k in keys, if k in sols dot add bag of 0, else, or okay, and rem dot add append bag. And then we just want to break out of that for loop. or k equals shiny gold. I think this might be it. Unhashable dictionary. Dang it. Okay, so this does need to be a list. Oh, it's running. Probably have an infinite loop. Oh, let's add another set of nsols, which are known wrong answers. There's probably a better way to do this, and we'll clean this up later. So we need to have something that's checking like all. No, let's just call it no chance. No chance is equal to false. And then we've just got a if no chance, no chance is equal to true, sorry. True, no, if no chance, nsols.add bag, ram.append bag. So this is the case where none of the bags inside of it, or all the bags inside of it, are guaranteed to not be a solution. So if not k in nsols, no chance equal to false. And then we also need that here. Unhashable type dict. Okay. Line 33. Fine, I'll make this a list too. Let's add something that's stuck at 362. Shoot. Okay, so nothing's getting removed. That's not what we want. Let's just print the bag. this is going to be a slow day because I didn't get in it quickly. Oh well. Okay, so a bunch of things did get removed, and we've got, let's just look through this. Okay, so these are things that are empty. And that got removed because it contained a shiny gold. Contained shiny gold. Empty. Vibrant gray. Wait, why did this get removed? Yeah, you know what I'm interested in is everything. That's way too much information. Okay. Ah, that's interesting. Okay, so it looks like our solutions are just text, and the not solutions are sometimes text. So that's our problem. Ha 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 ha. Okay, so instead of, because we just want the key. We just want the key. We don't want the and sols.append. Okay, so sols is being appended bag of 0, so we want nsols to append bag of 0 as well. And remove can append bag, that's fine. nsols.append bag of 0. Let's just see what happens here. 222, okay, let's... Right answer, okay. Very slow, but fine. Okay. Expensive to fly, shiny gold. So in a single shiny bag, 32 bags. Of course, the actual rolls have a small chance of going several levels deeper. Count all the bags, even the nesting them is topologically impractical. Okay, so this is just a sum thing. This is going to work great, and we need to keep track of multipliers as well. But it's just going to be a nesting thing, and the work that we did in the first half is going to be helpful here. So that's that thing, and L2 gets clobbered by this. So let's make a copy of it, or you know what? We're just going to reconstruct it because I don't feel like copying it, because I think we'd have to do a deep copy of sorts. And let's just print L2. Hey, got all the things. Okay, so now what we need to do is we need to figure out you know what we really need? We don't need this to be the list. We need this to be a lookup. So we're going to make it a dictionary. And it's going to be a dictionary that leads from color to dictionaries. So instead of L2.append, it's just going to be L2 of color equal to other. Clear olive maps to that. Excellent. Okay, so now we need to do a nice tree walk, which will probably work best with a function. Def bag bags, and we're going to take in the color and the dictionary. And what we're going to do is we're going to say return Okay, so let's just say num is equal to 0, or num, okay, so the number of bags, we want the number of bags that are required inside your SQL. So we want the number of bags that are inside of this thing. So number is equal to 0, and for C and D, for each color in the dictionary, we're going to say num plus equals, and the color D of C times num bags of C, so that's the color, and then the D, which is the dictionary. Oops, I don't know what just happened. Okay. Return num. Now we'll see if this works. Print num bags of shiny gold, and then L2 is the dictionary. Recursion error, yay! Okay. Let's just print out the... Why are we getting a recursion error? We don't have base case, but the base case is just if there's nothing in the dictionary. Oh, we're iterating over the wrong dictionaries. For C and D of color. And then we want D of color of C. 0. That's not right. That's very much not right. Okay. For... Oh, wait, we forgot to add 1. Because the number of bags is equal to the number of bags inside that guy plus the one that is that bag. 13,264. Whew. Okay, well, 811. That's not too bad considering how we've been doing on the other ones. Let's take a look how we did on part 1. I'm willing to bet it was terrible because we put too much thought into the numbers when we did not need to. Well, I can look at my own. 5 minutes to finish both parts? Wow. Okay. Personal stats. Yeah, 14,446. 1446. Not surprised at all. But we got part 2 in under 5 minutes, or a little over 5 minutes, sorry, which is kind of exciting. Cool. Well, I'm going to clean this up, but I think I'm going to do that later and I'll get it pushed in. But thanks for watching, and yeah, so today's problem was essentially a nesting problem. It was a search problem. It was these bags are connected by these directions where you say, oh, this bag is in this bag, and you have to trace through finding all of the bags that could be inside and how many bags are inside. So this thing right here is a nice recursive function that essentially just says, given a color of bag and this dictionary, how many bags are inside of this color bag. Base case is if there's nothing in it, then the number is 0. This for loop doesn't get triggered, and we just return 0. And the little bug that we had there was we forgot to count the bag itself, and numbags always return 0 if you don't count any of the bags individually. Cool. Well, see you tomorrow.